Hello, aspirants. A very good afternoon. Today, I'll discuss what we are going to cover for the recruitment of senior assistant electronics, and it will be applicable to Western region and Northern region. Since uh, conducting authority is same, exam conducting authority is same, post is same, then question paper will be almost same, or syllabus will be also almost same. And this is um the syllabus. Since the syllabus is same, then I'm discussing today the syllabus which I which is based on previous question papers, and most of the questions are being asked from these syllabus. And this is also applicable for Eastern region, Western region, and Southern region for the post of Senior Assistant Electronics and E6. And myself, Ravin Kumar. Today we'll discuss about syllabus. And now contents. What are the contents? We will discuss about exam pattern and then syllabus. Exam pattern means uh, how many questions will be asked, what is the timing, how the numbers are distributed, and what is the syllabus. Exam pattern, as I have told you in previous video, 70% questions will be asked from technical 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 uh, subjects from your diploma courses, whatever you have studied, either electronics and communication, electronics, telecom, and 30% question will be asked from general knowledge, general intelligence, general aptitude, English, etc. We will cover only 70% of the only technical questions only. But I'll help you how you can correct general knowledge, general aptitude, English, and general intelligence questions. And as you know, there will be no negative marking, so you can attempt each and every questions since there is no negative marking. Exam patterns. What is the exam pattern? There are total question is 120. 70% total question is 120, and 70% of 120 is 84. So 84 question will be asked from technical subjects, and rest of the questions, 36 questions. 36 questions will be asked from non-technical math, English, reasoning. Syllabus. Now we will discuss what is the syllabus for senior assistant electronics post. This is the syllabus. Electronic device and circuits. In electronic device and circuits, we will explore about what is semiconductor types, different types of semiconductors, their limitations, where to use which one, like gallium arsenide, silicon, germanium. Hmm? And then we will go for BJT. Here BJT we will discuss different configurations, biasing schemes, and then we will go for FET. And then we will discuss about Zener diode, rectifier circuits, half wave rectifier, full wave rectifiers, what are their advantage, disadvantage. And optoelectronics we will discuss LED, photodiode, optocoupler, solar cell, etc. And then we'll go for concept of feedback, positive feedback, negative feedback, their comparison, where to use positive feedback and where to use negative feedback. Transistor amplifier types, common base, common emitter, common collector. They are the transistor amplifier types. And there are other amplifier types also, which are based on MOSFET, most devices. And then oscillators. Oscillators are the circuits that are used for generating sine wave. Special semiconductor devices, SCR, die control, these are the high power devices, as you know. And filters. In filters, we will discuss in this section, electronic devices and circuits. We will discuss passive filters, wave shaping circuits. In wave shaping circuit, we will discuss clipping circuits, clamping circuits, voltage multiplier. All are made up of capacitor and diodes. Then we will go for multi-vibrator and Schmitt trigger using transistor. Schmitt trigger is the circuit that generate square wave or pulses. In electrical circuits, what will we cover? Basic DC circuits, Ohm's law, KCL, KVL, voltage and current division, series and parallel circuits, mass analysis, nodal analysis, their comparison, network theorem, Thevenin, Norton, maximum power theorem, superposition theorem, statements and simple problems. We will solve some numerical problem also based on these theorems. Since questions are being asked to find voltage, current, so these theorems will be helpful for us. Apart from these, what will we cover in electrical circuit? Basic AC circuits, average and RMS value, RL, RC, RL series and parallel circuits, resonance, three-phase circuit. In three-phase circuit, we will discuss briefly over transformer, three-phase motors, different types of motors, stepper motors, and two-port network, H parameter, G parameter, star and delta networks. Star and delta networks, in most of the exams, questions are being asked. There will be some complicated circuits. You have to convert it into delta network or star network to solve the equations or find out the current or voltage or power, whatever it is. In digital electronics, what will we cover? We will start from number systems. There are four number system: decimal, binary, octal, and hexadecimal number system, and their conversion from one unit to another. BCD conversion from one number system to other. Boolean algebra, Law and De Morgan's theorems, universal gates, NAND, NOR, realization of basic logic gates using universal gates means suppose there is a NAND or NOR gate, you have to convert it into AND gate, OR gate, NOT gate. You have to get the functionality from the universal gates. Tri-state buffer circuits, problem using 2, 3, and 4 variable Boolean expression. For output, simplifying a Boolean expression using map or K-map, constructing logic circuits for the Boolean expression. What do you mean by this? It means you have a Boolean expression and you have to construct logic circuits, arithmetic operations like adder, subtractor. In this, we will see half adder, full adder, half subtractor, and full subtractor. What is their equation and how to make a full adder, full subtractor from half adder or half subtractor. Then 2's complements, 1 complements, based some problems. Sign binary number system, arithmetic circuits. These are the adder and subtractor. Then combination circuits like mux, demux, decoder, encoder. Sequential circuits will be there. Some D type, D flip flop, T flip flop, RS flip flop, JK flip flop, and counters, up counter, down counter, synchronous counter. And in digital electronics, we will also discuss about shift registers, which is a part of digital electronics. Microprocessor and microcontroller. In microprocessor and microcontroller, we will cover microcontroller 8051, its different pins, programming, peripherals, its functionality, and how to interact with the stepper motor or DAC or ADC. Apart from 8051, we will also discuss 8085 microprocessor architecture, ISA. ISA means instruction set architecture and programming, and interfacing with memory, keyboard, display, etc. Industrial electronics. Electronics, we will cover power devices like MOSFET, IGBT. These are the high power devices. Via characteristics and applications, trigger circuits for SCR. SCR is silicon control rectifier. DC and DC triggering, UJT triggering, converters, and choppers. Inverter applications, basics of PLC. PLC is a hardware or programmable logic controller which is used in industry to control different actuators based upon inputs from sensors. And then we will cover linear ICs and op-amp. This is entirely covered on ICs like IC555, IC565, IC566. These are the timer ICs, and some regulator IC like 7805, 7812, 7815, and negative regulators like 7905, 7912, 7915. So In ICs, what will we cover? Timers IC and regulator IC. And in operational amplifier, we will discuss how operation amplifier is made from most devices, what are their ideal characteristics, and different type of circuits. In parameters, we will discuss slew rate, virtual ground, virtual ground, power supply rejection ratio, common mode rejection ratio, common mode gain, differential mode gain, and then circuits based upon op-amp like inverter, shimmer, inverter amplifier, non-inverter amplifier, adder circuits, subtractor circuits, voltage follower, differentiator, integrator, and instrument amplifier. Instrument amplifier is used in biomedical applications. And we will also discuss for comparator, zero crossing detector, waveform generation like based on symmetrical only. Symmetrical is a circuits that generate square wave. RC low pass active filter, A to D conversion using ramp method, successive approximation, dual slope method. So these are the A to D converter. We will discuss these things also. And next, instrumentation and measurements. In instrumentation and measurement, we will cover measurements, what measurement is, performance characteristics of measuring instruments like precision, what is accuracy, repeatability, signal and response of measurement systems, sensor and transducers. What is the difference between the two, and different type of sensors and transducer? They are pneumatic transducer, signal conversion, temperature measurements, temperature we will discuss temperature sensors, pressure measurement, pressure sensors are there, level measurements, flow measurements, telemetering, measurement of resistance, potentiometer, and some bridges. And important concept of in instrumentation is CRO, cathode ray oscilloscope. So, and next is communication engineering. Communication engineering, we will discuss some what communication engineering is, some modulation techniques like amplitude modulation, frequency modulation, pulse modulation technique, audio and video systems, and transmitter and receiver we will discuss in computer engineering. In computer engineering, we will also discover networks, filters, antenna and propagations. And the last but not the least, course duration will be 3 to 4 months. I'll cover the entire syllabus into 3 to 4 months. Thank you. And I would like to inform you that this course will be on paid basis. And for more details, you can drop me a message or mail me, which I'll mention in the details. Thank you.